Clemmensen condensation completed, my dears. See, in that Clemmensen condensation, one question I will ask you. So what is that question? If per suppose, see, today topic is Clemmensen reduction, but the question is Clemmensen reduction. What is the product? Have to say. I can explain this is next class, my dears. So be focused, right? See, CH3, C double bond, CH3, right? And ester, C double bond, O, C2H5, C2H5. So in presence base, that is C2H5 O minus, right? This is first, right? In acidic medium. In acidic medium. So what is the product? What is the product? Observe carefully here. I can give one hint. Here, this is alpha carbon. Alpha carbon contains alpha hydrogens. So this is also alpha carbon. It contains alpha hydrogens. So now, what is the question is that? That question is that the C2H5O minus will abstract the proton from ketone or ester. Ketone or ester. Right? Ketone or ester. See, my dears, this is for your what this is. Try to do this. Next class we'll discuss. Next time reaction we'll discuss. So please take down and write the product. Right. So this is last lecture, the Clemmensen condensation, about the Clemmensen condensation. Please take down, my dears. Right. Now, what is the name of reaction today? We'll discuss. See, that is Clemmensen reduction, my dear. Clemmensen reduction. It is very, very useful according to JEE point of view as well as NEET also. It is conversions. In conversions, the Clemmensen reduction is play very important role, my dears. Right? Now, let's discuss about the Clemmensen reduction, my dears. See, what happens actually, the Clemmensen reduction, what says? Observe carefully here. The Clemmensen reduction, be focused, my dears. Once, look at the board. Here, the CH3, C double bond, CH3. See, this is what? Ketone, sir. Ketone, right? This is aldehyde, sir. What is this, sir? Aldehyde, sir. Ketone, aldehyde. Aldehyde. See, the ketones and aldehydes to convert alkane, sir. To convert alkane. See here, if you add zinc amalgam by HCl, zinc amalgam by HCl. So what happened here? Observe careful. This group, C double bond carbonyl group converts to methylene group, right? Converts to methylene group. Be focused. CH3, CH2, CH3. Observe careful. See, sir. Carbonyl group converts to methylene group. That's all, my dears. So, and moreover, what about this, sir? Same. Zinc, amalgam, HCl. After that, what happened, my dears? CH2, CH. So this group converts to what, my dears? Methylene group. See, sir, what it means of reduction? Sir, reduction means removal of oxygen or addition of hydrogen, or else decreasing oxidation state. So this is not important, right? So here, what is that important actually? Observe careful. The C double bond O converts to methylene group. So that is very, very important. So reaction and reaction mechanism is very, very, very important, my dears. Be focused. In this Clemmensen reduction, so what happens? carbocation will form as an intermediate. Will form as a intermediate. So that is the reason rearrangement takes place. Arrangement takes place rearrangement takes place, my dears. See what I want to say, that observe carefully. In that Clemmensen reduction, right, carbocation will form as intermediate. That is the reason rearrangement takes place in maximum cases, not in every case, right? Maximum cases the rearrangement takes place, my dears. This is very important point, have to take down in any circumstances, please, my dears, humble request, have to take down this, right? Now here, see, be focused. I will ask one question, right? See here, what is that question? Observe careful. C, NH3, C double bond, C2, H5. If I added what? Zinc amalgam by HCl. And moreover, the very important point, at a time the zinc and HCl should not add, my dears. Why? Because Zn and HCl will react each other. The Clemmensen reduction could not happen, right? I hope you clear, everyone. So first you have to add zinc, after that chlorine, my dears. So just listen and forget, right? So what is that important? That the carbonyl group converts to methylene group. That is very important. You have to remember, right? So now see, what is a product? See, generally. So according to above reactions, the usually, right, NCH3, CH2, CH3, right? See, sir, this carbonyl group converts to methylene group, right? Generally the students will think that, my dears, right? But this could not come as a product. So what is the reason? The reason is that the rearrangement takes place. Just now have to take down this after when applications comes. So this is, I will discuss over there, right? Please take down this. First, reaction and mechanism. I will take sorry, where should I, there, the chalk, where is my chalk? Right, here the chalk, right? See, I'm taking the ketone, right? First, reaction, see, my dears. Observe careful. CH3, C double bond, CH3, right? Added zinc amalgam and HCl, right? What is the product? The product is CH3, C double bond, CH3, right? Sorry. The brain is absent, right? I'm checking, are you listening focus or not, right? Please once again, see here, CH3, CH2, CH3. See, my dears, this is very important. The carbonyl carbon, right, converts to methylene group. This is very important, my dears. See, the mechanism, very important. Observe careful. The mechanism. MEC stands for mechanism, right? The first of all, CH3, C double bond, CH3, for our convenience I have written like this, right? Now, what happens? See my dears, heterolytic cleavage takes place, this gets negative charge, carbon gets positive charge. In most cases in organic chemistry, right? So heterolytic cleavage takes place in most cases, not maximum cases, right? So this oxygen gets negative charge, carbon gets positive charge. So what is the reason, sir? I hope you know that actually the oxygen electronegativity is more than the carbon. So that is the reason oxygen gets negative charge, carbon gets positive charge. Here the one bond means what, my dears? Actually, see here. One bond means two electrons. How many electrons? Two electrons. See, sir, the two electrons are shifted on oxygen atom site. On oxygen atom site. So this is called as heterolytic cleavage takes place, right? I hope you clear. Once again I repeat. Here observe carefully, my dears. One bond means two electrons. So when heterolytic cleavage takes place, so the two electrons shifting towards the oxygen side and opposite side, what happened? Positive charge will come, my dears. Positive charge will come. So in simple language, just heterolytic cleavage takes place, oxygen gets negative charge, carbon gets positive charge. That's all, right? Now observe carefully. What happened? Here, H plus attack set here, my dear. Attack set here, sir. H plus, how it will come, sir? Sir, HCl, observe careful, sir. HCl dissociates H plus plus Cl minus, right? Cl minus. So this H plus attacks at negative side. One positive, one negative becomes what? One bond, my dears. See here, the very important point. What I want to say that here the one positive, one negative will become one bond. Right? See here. The next step is CH3 C, right? OH. Here the positive charge. What, my dears? Positive charge. Clear? I hope you clear, everyone, right? See, this H plus attacks it here, so it makes one bond, right? Now observe carefully. Now this is very important, my dears. Zinc, right? Zinc, how it will be, what happens, it's zinc actually participate in oxidation, right? Sorry, the zinc loses two electrons. How it will be? See, my dears, Zn plus 2 plus 2 electrons, right? This is loss of electrons, is called as oxidation, right? Now observe careful. One electron, relative charge is -1, my dears. Observe careful, this is very important, right? See, one electron equal to -1, that is relative charge of what? See, one electron means -1, my dears. Relative charge of electron, relative charge of electron is -1. Now observe careful. If one electron attacks it here, so that time what happened, my dears? Observe careful. Actually two electrons are there, right? Now one electrons attack it here, one positive, one -1 becomes neutral. After that the next electron attacks it again here, so that time what happens? This carbon gets negative charge, this carbon gets negative charge. I can repeat once again, my dears. This is very, very important step. So listen careful. Actually, 2 electrons are there. The first electron attack it here, right? So what happens? One positive and one negative will becomes neutral, right? Neutral, one positive, one negative, it becomes neutral, and second electron attacks it here on this carbon. So what happens? It gets negative charge. I hope you clear, everyone, right? So see sir, observe careful. Now what is the next step? See here. The next step is CH3 C minus, here one CH3 and OH. Alright. Now observe careful, my dears. Observe careful. Again I added HCl. Sir, HCl, how it dissociates, sir? It dissociates H plus plus Cl minus. Cl minus. Right? Now here, this, where is that yellow chalk? Right. This H plus attacks it here. This H plus attacks it here. One negative, one positive. What happened, my dears? It makes one bond. Example, see, my dears. This is positive charge. This is negative charge. Right? If to come closer, so what happens? It makes one bond. One negative, one, sorry. Right, this is positive, this is negative, no. So it makes one bond. That's all, my dear. That's all. See, what I want to say that, see, one negative charge, one positive charge. Observe careful. This is negative charge, this is positive charge. If come closer to make a bond. That's all, my dear. That's all. Right. See here. CH3. Now, CH3. Here, H. This is OH. Right? Negative, one positive becomes one bond. Now observe careful, my dears. This step. Observe careful. Here, what happens? Again, HCl I added. H plus plus Cl minus. Now this oxygen has electron pair. Electron pair is negative charge, right? Very clear. We know that, sir. Electron has what relative charge is? Relative charge is -1. So that is the reason here minus charge will be, right? Now this positive H plus will attacks it here, right? It attacks it here. So one H plus, one electron pair will make a bond. That is very, very important, my dears. What I want to say that, see here, one negative charge, one positive charge become one bond. Point number 1. Point number 2, one electron pair and one positive charge also make a bond. So that is very important, my dears. So here, observe careful. Now, CH3, CH3, OH2, right? Already H there, this H attached over there, so that is the reason OH2 have written, right? OH2 have written. Now see, observe carefully, my dears. Observe carefully here, right? So when, right like this, when oxygen gets 3 bonds, so what happened, my dear? It appears positive charge. So see, observe careful. One H plus attacks over there, so oxygen gets 3 bonds, my dear. 1, 2, 3 bonds. So when oxygen gets 3 bonds, what happened? When oxygen gets 3 bonds, oxygen gets positive charge. Oxygen gets positive charge. That's all, my dear, that's all. So, now, after that, my dear, see, observe careful. Heterolytic cleavage takes place. Heterolytic cleavage takes place. Sir, what happens? Oxygen gets negative charge and this carbon gets positive charge. Observe careful, one positive, one negative. What happened, my dears? It becomes neutral. It becomes neutral. That's all, my dear. That's all. See, removal of minus H2O. Clear? Now B focus. B focus here. The CH3 CH3 here, positive charge there. Swaha. This positive charge I will write on yellow color chalk. Positive charge. Right? Positive charge. Listen, my dears, once again. See, this heterolytic cleavage takes place. Oxygen gets negative charge, carbon gets positive charge. One negative, one positive becomes neutral and it leaves minus H2O. Right? Remaining part have written here, my dear. Right. Now observe careful. Observe careful, my dears. Observe careful. Here again added what? Zn plus 2 electrons. Right? Zn added again Zn and Zn. Sorry, I added Zn. So what happens? Zn gives rise to Zn plus 2 plus 2 electrons. 2 electrons. Now here, observe careful. The first electron attack it here. So that time it will be neutral. The again second electron also attack over there. Right? Attack over there. So that time what happened, my dears? This carbon gets negative charge. That carbon gets negative charge, my dears. CH3. Here H. CH3. Right? Here negative charge. It appears negative charge. Right? Now what happened, my dears? Here the HCl, if add H plus plus Cl minus, right, it dissociates. If added HCl, what happens? H plus plus Cl minus. Now this H plus will attacks it here. Attacks it here. Right? See, sir, one negative charge, one positive charge. What I said, it becomes a one bond. It becomes a one bond. That is finally CH3, CH2, CH3 will form. See, my dears. See, C double bond or carbonyl group, carbonyl carbon converts to methylene group. Here the carbonyl group converts to methylene group. Right? I hope you clear, everyone, my dears. Right? Please take down this in your class notes. Right? Fast.